Today, let's start on polygons. First, we start by defining the term polygons. A polygon. A polygon is any plane shape with three or more closed sides. So when you consider plane shapes with three or more closed sides, first we have to consider a triangle which has three sides. Right. For you to understand about polygons, the properties of polygons, first let's consider this table. We want to play a game. The rule of the game is such that we draw a straight line from one vertex to the other, and we do not want a line that crosses another line. So that's the game. That's the rule of the game. You know, every game has a rule. Right. Now, for a triangle, it means we do not draw any line, because there is no line which we can draw from one vertex to the other, except those lines that are already there to make a triangle. Right. It is one triangle. Let's go on to a quadrilateral. For a quadrilateral, it means we can draw a line from this vertex to that vertex. But we cannot draw another line from another vertex like this one to that, because it will cross this one. We said we do not want any line that crosses another line. So we just want a line that starts from one vertex to the other. When we say vertex, we are saying we are referring to a corner like this, to an angle. Are we together? Right, we go on to a pentagon, which is with the 5 sides. Right, we can draw from this vertex to that vertex, then from the same vertex to the other vertex there. But we cannot draw from this vertex to that, or from any other, from this one to that. We cannot, because we do not want the line that crosses another line. That's what we should avoid. That's the rule of the game. And we go on to the hexagon, that is with the 6 sides. With the hexagon, we draw this line from that vertex to that one, from this vertex to that one, from this one to that, and no any other line. Now, let's start the columns. We want to find out what relationships can we find between any two columns of the table there. Right. We want to compare, or to find out the relationship between this column and this column. The column of number of sides with the column of number of triangles. Right. When the number of sides is 3, the number of triangles is 1. When the number of sides is 4, there are 2 triangles. When the number of triangles is 5, when the number of sides is 5, there are 3 triangles. When the number of sides is 6, there are 4 triangles. It follows that to find the number of triangles in any polygon, we must consider number of sides, then we subtract 2. There is a difference of 2 between number of sides and the number of triangles in any polygon. There is a difference of what? 2. So we can say number of triangles is equal to number of sides minus 2. Right. With this, let's consider the question. Right, we are saying you can note that number of triangles in each polygon is equal to n minus 2, where n is equal to the number of sides. Which means now you can answer the questions. How many triangles is a polygon with the following number of sides? Right, 8 sides. How many polygons, how many triangles are in an 8-sided polygon? Right, with an 8-sided polygon, we have 6 triangles. With a 12-sided polygon, we have 12 minus 2 is what? 10 triangles. With a 32-sided polygon, we have how many triangles? Right, it's food for thought. That one. Right. It is also indicated. Let's go back again. We want to go back to compare and comparing the columns. Right. Let's consider number of triangles and sum of interior angles. You find that sum of interior angles is equal to number of triangles times 180. Why is it like that? Because we know the interior angles of any triangle add up to 180 degrees. The interior angles add up to 180 degrees. So the number of triangles, each triangle is 180. So with the two triangles, we have 2 times 180, because this one is 180, this one is 180. So the sum of interior angles is equal to number of triangles times 180. So we can say here, if it is 2 triangles, it means the sum is equal to 2 times 180. With the 3 triangles, the sum of interior angles is equal to 3 times 180. With the 4 triangles, sum of interior angles is equal to 4 times 180. So we can tell that the sum of interior angles of any polygon is equal to number of triangles times 180. So we can write down an expression for sum of interior angles of a polygon as number of triangles times what? 180. But we know that number of triangles is equal to n minus 2, where n is the number of sides.